Hey, what's up everyone? This is Corey Glenn, and I'm going to do a video here on a cool new product called the Quikbar. Again, full disclosure, I have nothing to gain by doing this other than Lambert Stumple, who developed this product. He's a really cool prosthodontist out in the Bay Area in California. He's been kind of a hero of mine since back in Dental Town days. He's very much a tinkerer. He finds out cheaper, more efficient ways to do stuff. So I've always loved watching his stuff, and true to form, he's developed this product, which is an option for building a chairside bar or metal reinforcement inside of a temp, which is very much a needed thing if you're doing 3D printed prosthetics like this. Because one of the things we find with the printed prosthetics, and even PMMA to a degree, is that they have great compressive strength, but they don't bend well. And so the risk whenever you do printed prosthetics is that they can just fracture this thing through and through, and now you're kind of dead in the water. There's not a lot you can do. But with that said, if we can have a metal reinforcement, a bar type structure internal, then these can end up being incredibly strong. And I'm going to make the argument that they should be considered as an option for final prosthetics. So let me get on my soapbox for just a moment. It always bothers me that we as dentists tend to just think too simplistically. So we've got our options for a person who wants full arch implants, right? Well, we go from a 2-implant overdenture, let's say it's $5,000. And then the next option you've got is your full-on zirconia hybrid, the whole works, for $25,000. Like, how many people can make that jump? I mean, I make good money, and that's going to intimidate me. And so I think it's a shame that we as dentists don't try to think of outside of the box options that we could make affordable restorations for our patients. And yeah, maybe they're not your Cadillac best of the best option, but who freaking cares? It doesn't matter at all to me. I mean, that's like giving the option of a Ford Taurus, and if you're a car dealer, you've got a Ford Taurus, and then you've got a Bugatti or a Lamborghini. It's like, man, most people want something in between. They want the Maxima. They want the Camry, right? And we don't, as dentists, generally give patients options like that. And I think it's a shame, because we could help a lot more people if we would create some in-between options. And as long as the patient's informed and knows the pros and cons of whatever treatment modality they're choosing, well, great. Who loses in that scenario? So off my soapbox, but where this is most evident to me is in the full arch implant world, right? Because again, we go from just an overdenture all the way up to next step is zirconia hybrid. Well, now with the advent of printing, with people having in-house mills, you can make restorations in-house for next to nothing. So this is a 3D printed superstructure to go over this bar, which I've already created using the Quikbar. And if you pick this up inside of this, and then you can even fully wrap your bar with resin, with more printing resin, with acrylic, whatever the case may be, now you have a really nice looking restoration, monolithic superstructure, and bar reinforcement internal. And I would challenge you, what is the mode of failure on this, right? So if you're thinking about, oh, I'm too good to do that, like, well, tell me, where is the mode of failure here? You know, it's not going to break through and through. It's simply not. You know, the amount of force that you can put onto this in the mouth is not great enough to break through this metal bar and this superstructure. So in this scenario, the only mode of failure I'm really considering is chipping of the resin. So let's say they bite fishing line and they chip a tooth. Well, okay, cool. I mean, hopefully you explain that up front if they chose this option. And if they do chip it, you break out your bonding agent and your composite and you fix it, right? This is resin, it's easy to bond to. So again, I just think this is an option that is way underutilized, and I don't need a mill to do this. I don't need a metal printer. I don't have to be able to cast. I can just make this chairside or on a model. I'll have incredible passivity. This is actually the same level of passivity you could achieve from something like an iMetric or a photogrammetry unit, right? This is kind of the poor man's method. And this all operates off the Cal technique, which if you're unfamiliar with that, look at my old videos. But the Cal technique, I think, is so underutilized, and it's the only other way I know of that you can achieve that same level of passivity as you can with photogrammetry, but in a low-tech method. Okay, so let's just go through these parts. This is how the Quikbar comes in a packet like this with just all these stock parts. So I've got this dummy model, right? Let's say you've placed implants. You don't have to do it guided. This could have been a freehand implant case, but now you're wanting a metal substructure within that restoration. So we can just build it, okay? So it comes with these little wings. These parts are designed such that you can slide the tube over the implant, right? And these wings will interlock like that. So you could actually have resin in between here. And when I position those things together and then cure it, you know, it can't flex this way and break through and through because the wings are interlocked. Hypothetically, you know, maybe you've still got the slightest weakness where it would hinge like that, but you can't put that kind of force on a restoration in the mouth. You know, if you just wishbone this, that's not a force that you can do in the mouth. Your forces are axially. And so this is a really nice option. Again, this is a completed bar that just took a few minutes to make on these models. So let me just show you how this would work. So we've got these two implants, right? And they're whatever proximity to one another that they are. I can grab a couple of these units, right? And that one could be dropped on, and then I can pick one of these others, and then I just swing these to interlock over one another, okay? Use the light cured resin of your choice. I suppose you could use a dual cure material too, like the Stellar pickup material. You could even use acrylic, I guess, if you wanted to. You just got to lock this together. I like to use this product called Primo Pattern, because Primo Pattern is the lowest shrinkage of any material we have basically in dentistry. It's a light cured pattern resin, meaning it, you know, you can build a structure out of this and then it can be cast. But the reason I like it is because when I do this pickup, it's going to fill in between here. And when that gets light cured, the fact that it shrinks so little, and just to give you a reference, I won't quote this exactly, but I think acrylic is in the range of like 7% shrinkage. This is like, you know, point something percentage. So really low shrinkage, okay? And you can get it in clear and red. You can get it in the gel or in rods. All of that works. So all I would have to do here is, let's say this is in the mouth where I'm building it, because that's the ultimate test of passivity, is in the mouth. So the first thing I would do is just squirt the resin in between the wings on both of these, and I'd just do these two at a time. I'd orient them together like so, kind of thinking about my arch form, because we're going to have a superstructure over this, and then I would light cure that. Now those are locked together. And then I would pick this up. Now you might do this after you've created the whole bar structure and then pick it up all at once, or I could do it now, but I could squirt this between here. For that part, I do like a dual cure material, because I want to ensure that it's fully curing internal where the light can't get to very well. Okay, so I would do that. Now let's discuss a scenario where you've got two implants that are too far apart. All right, so here I'm going to grab these two. All right, so that one goes on and this one goes on. And obviously these two implants are too far apart. It's not going to reach. So how would I deal with that? Well, you've got this little thingy, okay? So this is just meant for being trimmed. So if I was really doing this, and I'm not gonna cut this, but you'll get the idea. I can just lay this between these two implants and the temp cylinders are on, and I could just say, okay, I need to cut that to right here. So now I cut that with a cutoff wheel or a carbide burr, and I've just got this. And now that becomes what slides in between. So here, again, this is not the greatest demo, but imagine now that you've got that filling the span. Again, you've eliminated the ability to get that through and through break, because even though this is thin, it is incredibly strong. It feels like titanium. I'm not 100% sure that's what it's made of, but it's a really strong alloy. Okay, so now that would make your long spans. Now you'll have other scenarios where you do these, and like probably if I had a cylinder on this one, it's almost touching that one. So when that's the case, just take it to your grinder or take a cutoff wheel or whatever and just shorten this slightly. Okay, so you kind of want to dry fit everything and make sure it's interlocking together properly first. Then you're just flowing in the resin and curing it all together. And then you pick it up to the implant cylinders as well. So as part of this kit, you get the titanium implant chimneys. They've already got this grooved surface, so everything bonds to them well. It comes with the multi-screw. So that's the idea. And in just a couple of minutes, you could form a bar made in the mouth, which is, again, the best test of passivity. You know it fits, right? You're curing it on the cylinders in the mouth. So you've got a really passive restoration, and I just see absolutely no downside to it. And now there's a lot of ways to accomplish the same result. You know, I've shown the tri-lower bars in the past, which are another great alternative to this. You know, this is a tri-lower bar, so if you had your temp cylinders, you could set this on and just mark the spot where each cylinder is hitting, punch a hole through there, and now that would slide over all of your titanium cylinders, and you pick that up with the resin of your choice. Okay, and then you just shave this down to size. That's an option that works really well too. And in fact, I've made some of these ahead of time. So this one has tri-lower internal, and I absolutely cannot break this. This violates, you know, I don't have the standard 15 millimeters of space, but even trying to wishbone this, I am squeezing with all I've got, and I can't break it. It's virtually indestructible. Again, the weak point is that they chip a tooth, which is easy to deal with. This one actually has the Quikbar components in it. So let's try that one. Let's try it outward. I can't do it. So again, this is not the prettiest one because I did a quick and dirty gingival job on it, but you hopefully get the idea. Notice that it's fully ovate or convex on the intaglio, because this here I picked it up with denture pink resin acrylic. So this is all embedded in there, and it's just really strong. And that's my goal. Again, I want options somewhere for the in-between patient that can't afford to go all out, but wants to have an option for full arch implants. So I made this bar internal. You know, once you've cured everything together, I'll typically put it in my 3D print curing oven. I've got a high power oven, and I'll just let it do a 5-minute cure to really solidify it and get light from all angles. You can see here I used this clear Primo pattern resin, and then I can just go around with a rubber wheel, any kind of abrasive thing, a diamond burr. And if I have some of these wings that are maybe sticking too far out, I'll just chop them, right? They're easy to adjust, and that can be dealt with. So now, this is my bar, directly fabricated in the mouth, 100% passive. You know, we could do the single screw test, which I have done, and everything is perfectly flush. So great passivity. I don't really think that you could improve on the passivity with photogrammetry or any other method, frankly. You can see here, hopefully you can see internal to this, these two wings, they didn't meet, so I have that section of this where I chopped it to that, and that is residing in between here. That's what's bridging that gap on these implants that are too far apart. These two, where they were really close together, I just shortened my wings a little bit, and then still they were they were interlocking. Couldn't find the word. All right, so that's the Quikbar. Now the question is, how do you make the superstructure, right, that you're going to pick this up in? Well, there's a lot of options. You could have made a shell denture ahead of the procedure and then just pick that up. You could have done a traditional denture and just hogged it all out internal until this thing fits over it. I think those are a bit imprecise and would have a lot of adjusting in the mouth to get it seating fully, and then how do you manage occlusion, all that kind of stuff. So if I was clinically doing this on a patient, what I would do is generate my bar first, and now just do an intraoral scan of this. Or if you got models and you're doing it on models, do a scan of this. And now you've got a model, and you can carry that into the software of your choice. I used a Blue Sky plan, and you're just designing a denture, right? Because you can indicate a path of draw straight over this, and then you're just designing a denture without flanges. Okay, so this seats right over the top here. And there's only one way it's going to go in. Like, this is a precise fit, so you don't even have to pick this up in the mouth. I could do this on the bench top like this. So get a dual cure resin of my choice. I would fill this well. Okay, fill the well with dual cure resin, and I'd squash this thing in. There's only one spot it can go, and then I'll just keep this held together as this sets. Once it sets, take some either acrylic, or I would probably use this 3D printing resin just on a brush. This was Ceramco's Crown Tech. I would just take some brushes and I would fill over the top of that so that I'm fully encasing that bar. Really, all I want to see is the underside of that multi-unit cylinder, kind of like this or that, right? I don't want to see the bar. I want that to be fully wrapped. And if you didn't do some kind of contouring, you would have concavities on this, and that's an absolute no-no in full arch. So after this has been picked up, just take the resin of your choice, flow it in, right, light cure it, flow in a little more, light cure it, until you've got this thing fully wrapped. And now that's your final restoration. It's either a super, super strong, virtually indestructible, long-term temporary, or it's an affordable permanent that you could do for anybody. So, I mean, all in on this, let's just discount the cylinders. Cylinders are 20 a piece or something like that. But your only cost is the Quikbar components, and then the 3D printing of the superstructure, which is maximum $10. And the point is, you would have a $100 to $200 restoration, no lab bill with it. You can make it look as nice as you want to. Okay, so if I just made a video of staining this is Taub stains, but if I was going to do this as a long term, I would either stain it and then put the translucent flowable pink gingival composite over the top to give it some thickness where that can't just wear away. Or I would just not even do gingival festooning here. I would maybe even leave it cut back and just apply a gingival composite, because that you can't abrade away. That's going to be on there for the long haul. Glazed over the top, this is a killer restoration. And again, for dirt cheap, with no lab bill, with not a lot of effort, frankly. So I really, really like this option. Basically, I would pick this up, I'd wrap it, and now this can be delivered in the mouth, okay? I haven't gone into how you capture vertical and everything, because you would do that just like you do on any case, right? With a denture or whatever. Like I could even, if I'm trying to get a centric bite and I've made the bar in the mouth like this, well, if that bar is screwed in, I could take a leaf gauge and just stick leaves in until they're at the right VDO, okay? That puts them in centric, condyles are seated. I've already gotten an intraoral scan of this. I've got an intraoral scan of the opposing. And then for the buccal bite, again, maybe I've just got them biting on a leaf gauge and I've added enough leaves to where they're in the right VDO. And then I stick my intraoral scanner in from the side and I scan here and up to the top, and that's my buccal bite. That sets my digital models in occlusion for when I'm setting the teeth. Oh, I did want to show one other thing. Notice I don't even have holes in the occlusion here yet. I do have the tiniest hole right there. I was going to show a method for that. So either I can be looking down this and know there's my channel and I can bore a hole through here, or I can grab a tool out of my other kit. So this is another great product, and I've made a video on this previously. This is a smart denture conversion. But one of the things that's included in that for the smart denture conversion kit is a drill. So imagine on the bench top, I've picked this up now and it's embedded. It's stuck in there, but I don't have occlusal screw access holes. Well, I can take this countersink burr and I can just, from the underside, I can bore my hole through. You could just as easily find a, a drill, a power drill that fits internal here, and put it in a handheld drill and just drill out through the occlusal aspect. And when you do that, let me find one of these. You'll eventually punch your way out like so. And now you know that's exactly your screw channel. And you keep your size of your screw holes to an absolute minimum. If you, you'll have to have a bigger hole than that, obviously, to get this screw through there. Again, I could rob this out of the Smart Denture conversion kit. And this is the countersink burr for the occlusal side. So once you punch through with the little drill, grab this one and put it in either a handheld drill or whatever. And now it finds its way with that tip into this, and I can countersink this direction, and that's going to precisely open up the hole to the dimensions needed for the screw. Okay, so you could spin it by hand or with the power drill, but as I do this, it's just boring its way through. And now I'd have the perfect sized hole, because this thing is designed to be the right size to mill out your screw access hole. And again, I like these drills from the Smart Denture conversion kit. No reason you can't just do that with any old handheld drill. Okay, so that's again, that's another great option for super affordable hybrids. If you got a 3D printer, which I think every dentist should have, and even the most basic digital know-how, anyone could make this. All you have to know from a digital perspective is how to do an intraoral scan, and then how to make a digital denture over the top of that, which I've got videos on. You could learn that easily. So I hope you found that helpful. It's a great product. Big fan of Lambert's. He makes some great products, and this is his newest one, so I wanted to make a video on it. Thanks.